So if you can keep the majority of your horsepower in the mechanical realm, which we're doing in the hybrid design through leaving the main engines there, and only make the electrical the size that you need to maximize or where you spend most of your time operating, then you really reduce the size of the equipment. So a diesel electric plant's not really possible in a hull form this size. So in addition to the cost savings, the hybrid just allows this to be enabled as far as the technology. So that's the main switchboard. That's it, another view. And that's the vessel out operating, Carol and Dorothy. It's just a picture of the switchboard. It's in place. Some of the operator controls, the HMI, and some of the new hybrid projects that we've done. We've just finished. Campbell Foss is now operating here in LA Long Beach, and it was a retrofit. That's its switchboard in our shop in Prince Edward Island. The HMI operator interface. This is the area where we installed batteries. So, in this case, lithium polymer batteries. The amount of space, if anybody's been on either of these vessels, the Carol and Dorothy has the entire forward bulkhead full of lead acid batteries. On here, we've got two small frame sections full of lithium polymer for essentially the same amount of energy. So it's a significant reduction in energy. And these are now classification, marine classifications are having to catch up to this new technology, and Lloyd's recently approved this type of battery technology. Okay, so this is Campbell Foss. I think this is just our HMI showing a graphical representation of the system. So this is something we developed in-house to show the transfer of energy between the various providers and consumers. And it shows, you can quickly look at it as an operator. They have this up on the wheelhouse. They also have it down in the engine room. In the wheelhouse, you can look at it and get a feeling for what the plant configurations and clutches will show if they're closed. It'll show which way the energy is flowing through arrows, and will show kilowatts from each or through each of the power providers or consumers. Same sort of deal with the batteries. We show the battery spring voltage, the temperature of the batteries, general health of the controller, and the DC-DC converter. That's the Adrian. So the Adrian is in the Port of Rotterdam, and Rotterdam's been fairly progressive, not as progressive as Long Beach, LA maybe, but it has been, it is starting to push pretty hard for emission reduction as well. And as a result, a company called CoTug has engaged us to build the first, Europe's first hybrid tug, and that is now working in the Port of Rotterdam. Just to give you an example of what we've tried to focus on with the system design, it's been to make the design very compatible to any sort of vessel configuration. So what we did with the Carol and Dorothy was designed around making it capable of the things that we didn't know. Even if we ran into an area, we always had safety margin built in case it didn't perform the way that we expected it to perform, the way the modeling showed it would perform. So then in the Campbell, we were able to focus on designing more of a generic design that would work on multiple platforms. And then this design was able to be used on the CoTug job. You can see here it's got 3 propellers. It's got 2 ASDs up forward and 1 aft. So the design simply is almost like a checkbox. We're able to add another shaft line to the system. Obviously we need the hardware, but from the software and controls point of view, we've made it very flexible as far as that goes. So that also means it can be used on different types of vessels. It can be used in different applications, like crane applications, train applications, anywhere where you've got a duty cycle that meets the requirements for where hybrid would be advantageous. This is just some of the pictures of the CoTug. The guys in Rotterdam are really short, so we had to put all the gauges at the bottom of the panel. Actually, they're not. They're all about 6'6", and with the panels mounted up in the air like this. So, anyway, this is our HMI, some equipment in our shop working out. One of the things I want to talk about, this is neat. This was done by the University of California, Riverside, on the Carol and Dorothy. So the first vessel, they went out and Foss engaged in to do some third-party investigation or measurements as to whether the hybrid system was working as advertised, whether we were getting the savings that we expected. And we'd all obviously done some internal checks, so we wanted to get a third party in to validate that. So we took two vessels, the Alta June and the Carol and Dorothy. The Alta June is a sister vessel to the Carol and Dorothy, except it's conventional. So we took two vessels, the same hull configuration, operating in the same port, and then compared over a couple of month period, I believe, their operating profiles. And this is the percent of time that they spent under the various modes of operation, just to make sure we're comparing apples to apples type of thing. So almost exactly the same, 54 to 53% at the dock, 7% on standby, 17 to 18% in transit, and 22% in assist. And the results from the study, after all the data was analyzed and crunched, particulate matter reduction, PM reduction of 73%, NOx, SOx 51%, and CO2 27%. So that was and it actually, we were only really predicting on the CO2 what we would say, when we predicted between 25 and 30%, so we managed to go right in the middle there, so that was good. This is bottom line sort of stuff. That is fuel savings. So this is what generates the business case for operators, and is what we really get this technology to move through. You've got to make that business case to the owners. This is what increases the health, benefits of the system by reducing the emissions. It's greatly benefits the ports where these vessels are installed, obviously. So that was great. We're doing the Campbell FOSS now, and once we get that in place and get the results back from that study, we're hoping that we'll get EPA approval for the system, or recognition of the system as a certified marine hybrid system. So on that note, anybody have any questions they'd like to ask? Yeah.
Sure. Can you outline kind of like the differences in initial cost of implementing a hybrid tug versus a standard? And are there other, I didn't recall in the presentation, maybe I missed it, about whether there's reduction in overall fuel that's used as well?
Yeah. So on the cost side, Carol and Dorothy, we looked at that type of tugboat. Typically, I think the CapEx on that is about $8 million, and we were looking at $2 million for the system on our side. Then there were some shipyard costs with changes in configuration of the hull, but really not too much additional cost. You're talking about a new build. So pretty significant additional cost.
Is there also a change in the way the boats operate in terms of the captain, crew, etc., that is taken into account when you make these changes?
That's really good question. It wasn't really taken into account in the study done by the university, but it's kind of called the Prius effect, right? Mm-hmm. So you've got, once you put an operator into a hybrid car, they automatically drive the car more responsibly from an emissions point of view. So you do get that with this system as well, of course. The operators are constantly thinking about, am I running the plant in its most efficient configuration? Do I need to be doing 8 knots when I can be doing 6? Those sorts of things. So that does have, there is impact there just automatically from the fact that they're running a vessel that's supposed to be more efficient. All right, well.